So hello everyone. Today we are going to see the solutions of Leetcode Biweekly contest 80, which was on 11 June. So we are going to see all the solutions. So let's proceed to the first question. So in this we are given a password, and the password is said to be strong if it satisfied all the following criteria. So it must be of 8 characters. It should contain at least one lowercase letter. It should contain at least one uppercase letter. It should contain at least one digit. It should at least contain one special character, and special character should be from this string, and it should not contain two same characters in adjacent positions. So for example, AAB is not valid because AA are consecutive. So we are giving a password string, and we have to return true if it is strong, or otherwise return false. So for example one, this is the password given. So as you can see, it satisfies all the following conditions given above. So let's proceed to solution. It is very easy question. So first of all, we get the special character, special string or special character from here. Then first of all, we check if there is at least one special character present or not. So f is equal to 0. This is basically a flag. So we iterate through all the special characters, and if the special character is present in the string password, then we do f equal to 1, means flag equal to 1. So flag equal to 1 indicates that there is a special character. If not, then we return false. Similarly, we do then of password is less than 8, then we return false. Now we check for if there is a digit present or not. Then again we do if there is a uppercase letter and lowercase letter present. Now we check for if there are two consecutive letter present which are same. So if there are, so we return false, else we return true. And you can see this is accepted question. So now second question. So in this question, basically the binary search was heavy. So like the second question and fourth question both involve binary search. So in this we are given basically two various spells and portions, and in which the spells of I represent the strength of I spell, and portions of J represent string of J portion. Now we are given string integer success. Spell and portion pair is considered successful if product of their strength is at least success. Then we have to return an array integer array pair of length n, where pair of I is the number of portions that will form a successful pair from I spell. So basically we have to create an array which is of length of spells, and so for example, we are at 0th index. So 5 multiplied by which all portions, like portion of 0 or 1 or 2, how many of them when multiplied by 5 the product is greater than equal to 7. So basically yeah, so coming to the question, basically I did the reverse for I reverse basically the spells and portions because I wrongly implemented. And now ignore this, and for in this I am finding, so first of all I find the length, we sort the spells. For example, p, so s into p of I is greater than equal to success. So p of I is basically spell of I. So p's portion is basically spell, and spell is basically portion, so keep that in mind. So s into p of I is greater than equal to success. So s is greater than equal to success upon p of I. So we should find all the s which are greater than this value. So we do that by bisect left. This is basically lower bound. We find the s, and answer of I equal to Reynolds spells minus s. So then we return the answer. So this is easy question. Coming to the third question. This is again very easy question. We are given basically two string s and sub. We are given two t character array mappings, where mapping of I indicates old I and new I, in which we can replace any number of old I characters of sub with new I character, and each character in sub cannot be replaced more than once. We have to return true if it is possible to make sub a substring of s by replacing 0 or more character according to mappings. Otherwise we should return false. So this is brute force question, fully brute force, and you can see by checking the constraints, it can be accepted of n into m. So we first find length n and m, the length of strings. Now basically what I want to do is I am storing dictionary of x. So x can be, so basically in the string s there can be uppercase letter, lowercase letter, or digits. So for like, so we can accompany all of them. I am creating array of 150. Now we are looping through mappings. We find the order of I, so the ASCII character, we find the order of that, and then dictionary of x. So basically dictionary is basically an array, and dic of x is basically a dictionary. So we index that, and we make we j is basically key, and j is basically key, and the value will be 1. So basically we are storing j dic of x. So now we basically create two loops for I in range n and for j in range m. If s of I plus j is equal to sub of j, then they are equal, so we should not bother and continue. If they are not equal, then s of I plus 1 should be in this dictionary of order of sub of j. If not, then we break. If it is, then we return to. If then if okay, so we can completely transform this string so that sub is a substring of s, then we return to, else return false. Now coming to fourth question. Again very easy question. The score of a subarray is the score of an array is defined as product of sum of its length, sum and its length. For example, score of this string is this array is sum into its length. Now we are given a positive integer array nums and integer k. Return the number of empty subarrays of nums whose score is strictly less than k. So coming to first test case, basically these 6 subarrays have score less than 10. So we can make one observation that we can find the subarrays which have score greater than or equal to 10 and subtract it from all the possible subarrays. So it will be much more easier. So directly coming to solutions, basically the thing is that we create a prefix array. So suppose this is a prefix array, and suppose we are at index I, and if we move from here to here, as we increase our subarray, then the sum will increase as well as the length will increase, so product will increase, so basically the score will increase. So as we move left, the score monotonously increases. So we can make observation here that we can apply binary search to find the point where the score just gets greater than the score, and basically if this is a point where sum gets greater than the score, then we can calculate the number of character in this subarray, and that will add on your answer. So basically from I till here and I to here, I to here, I to here, these subarrays will have score greater than k. So doing that only, we create a prefix array. We do binary search, low will be 1, high will be I, and mn will indicate the point where the score gets greater than k. So we find mid, sum will be this, and if sum is greater than k, so we should move right, so low equal to mid plus 1, else we should move left. As the score is increasing as we move left, we do this. Now if sum is greater than equal to k, then equal to max of comma mid. So now we add in our answer. Now is basically subarrays which have score greater than or equal to k. We have to find less than, so we decrement answer from all possible substrings and return that, and you can, as you can see, it is accepted. Kindly like the video and subscribe.